Turning back slowly, is still loving you more. Oh, hello, hi. Oh, hello, One Talks in Papua New Guinea, and to all my kababayan back home in the Philippines, and to all students around the world, wherever you are. If you are a grade 8 student, please, I hope that you come across to this video of my YouTube channel, Mr. Delicious. I am a teacher by profession, and since Papua New Guinea is having a 4 weeks of isolation, so the schools classes have been cancelled and for 4 weeks, and there are no classes for primary and secondary schools in the country, and therefore, as a teacher by profession, I would like to help the students. While you are in the house, let me reach you out in this video in my mathematics tutorial and coaching. Okay, so that you will be ready for the national examination. Now, I am going to have my presentation in my tutorial for the subject mathematics for the grade 8 students. Okay, so our first tutorial topic is on algebra. Now, remember, I am going to be doing a tutorial. So, meaning to say, since I am meaning to say, since I know very well about the national examinations, and because I have taught and I'm teaching grade 8, and therefore I know very well on the kind of questions that will come out, and the topics that will come out. So bear with me in this video. After all, this is for your own good, and I'm just trying to help you. Okay, now for the algebra, we have the simplifying algebraic expression, the simplifying algebraic expression, factorizing algebraic expression, and evaluating algebraic expression. These are the very common questions that you usually encounter in any mathematics questions when it comes to the topic algebra, especially in the grade 8 national examination. So, because this is quite long to discuss, I'm going to divide this one into 3. All right. So in this first video, we shall be having a simplifying algebraic expression, and then that will follow the factorizing of algebraic expression, and then the third one is the evaluating algebraic expression. Okay. So which means that there is a continuity of the video that I am going to, or the tutorial that I am going to do in this video. Okay, all right. So let us start. Mathematics is just all about having fun, and you don't have to be scared. Just imagine that you're just playing your favorite game. Okay, it's just like that. That is all. That's how mathematics is. You don't need to be stressed. You don't need to worry. Okay, just have fun in mathematics. Just pay attention to this tutorial. All right. Now, the first question is, how do we simplify algebraic expression? Okay, what is algebraic expression? What do we consider as an algebraic expression? So, as an example, if we have an expression of 5x. So this 5x is already an algebraic expression. Why it is an algebraic expression? That's a very good question. Any one of you who has the answer? Okay. Why is this 5x an algebraic expression? Okay. It is an algebraic expression because it consists of this one is what we call the literal coefficient, okay, and the 5 is what we call the numerical coefficient. Okay? So in other words, an expression is considered an algebraic expression if it has a numerical coefficient, and then beside to it is a literal coefficient, which is literal coefficient. These are letters that we usually that are from the alphabet, and we use it, and then that would be sitting together with a number, and then it become a algebraic expression. Okay, this is an algebra. Okay. Algebra is like that. We have 5, and then beside that is a letter, and that is an algebra. Okay, that is algebra. Okay, now once again, like what I've said, we are going to have a first presentation, first tutorial on the simplifying of algebraic expression. So usually it's all about, this is expanding, okay, expanding and simplifying. Okay, we have expanding and simplifying. Okay, that's the simplifying of algebraic expression. So how do we simplify? Let me present to you 4 steps here in simplifying algebraic expression. Number 1 is when an expression is enclosed with symbols. The symbols, the common symbols are the brackets and the parentheses. So when you see a very complex algebraic expression, and usually it's using a symbol or brackets and parentheses, those are a complex algebraic expression, and you need to simplify it. When you simplify, it means that you need to expand, and then you are going to collect like terms later, meaning collect like term is combining like terms. Now, what do we consider like terms? What are like terms? Okay, what do we consider like terms, algebraic expression? Like terms. So what are like terms? So we have here, for example, 5x, and then we have another one, 5y, and then we have 4x. Okay, which of these 3 are like terms? Which one? 5x, 5y, 4x. Which one are like terms? Yeah, come on, give me the answer. All right, very good, very good. The like terms are the 5x and the 4x. These 2 are like terms. Why? Why do you think that 5x and 4x are like terms? Okay? Yes, very good. The 5x and the 4x are like terms because of the lateral coefficient x and another x. It doesn't matter if the numerical coefficient 5 and 4 are different. All you need to do in order to identify the term to be like term is to look up in the literal coefficient x and x. Okay? So if it is like 5x squared and then 4x squared, then the 2 of them are still like terms because this one is x squared, the other one is x squared. Even if the numerical coefficient 5 and 4 are different. You get it now? Can you now identify like terms? Okay, what if I will say 2x and x squared and x? Which of the 3 are like terms? 2x, x squared, and x. Very good. Very good. You are really smart. You see, that's what I'm telling you. Mathematics is just all about having fun. Okay, so the like terms are the 2x and the x. Okay, the 2x, see, the like terms 2x, then x squared, and then x. Okay, so the like terms here are the 2x and the x, because why are 2x and x like terms? Very good. They are like terms because this one is x, the other one is x. So the literal coefficients are the same. Even if this one is 2 and the other one is 1, the numerical coefficients are different. But to check which of the terms or the algebraic expressions are like terms, you just have to check on the letters or the literal coefficient. Do you understand it now? Okay, very good. Huh? Because, you know, I don't want to waste time. Okay, so you must also do the same thing and make sure that you will give your 100% commitment in this tutorial. Okay, watch this video because remember, this is just the beginning. I'm just going to start it, and then up until you sit for your national exam. You just keep on watching this video, and you can also download it and then watch it many times. And I tell you, you will you will not worry anymore when you sit for your national examination in October. Okay, so don't waste time. Grade 8 students in Papua New Guinea, or any students in the world. Okay, grade 8 students. All right, next one. Okay, so there are 4 rules actually in simplifying algebraic expression. One is you are going to remove the brackets, and to remove the brackets, you're going to multiply it by the factors. I'll show you the example later. The second rule is when it is in exponential form, you are going to apply the rule of exponents. And then after you have applied step 1 and step 2, you can now apply step number 3, which is step number 3 is to collect like terms. To collect like terms, meaning that you are going to either add or subtract like terms. And then the final one, in order to simplify algebraic expression is from a very long expression, you're going to make it into small. That's what it meant by simplifying algebraic expression. From a very long expression like that, you're going to make it into small like this, and that is simplifying algebraic expression. Okay, the number 4 one is when to simplify algebraic expression, the part of the expression is the constant. So what are these constant? Okay, what are these constants? Okay, constants in algebra, these are actually numbers like 5, 6, 7, or 4. These are the numbers that separate the rest of the term because it is a constant. Constant doesn't have letter. Okay? It only stands there in the expression, in the algebraic expression, without any letter. That's why it is called constant or constants if it is plenty. You get it now? Huh? Come on. Okay? So this is very good. This is mathematics is all about fun. Okay? It's just like playing rugby or playing soccer. I'll tell you, if you want to be very good at playing soccer, same thing with mathematics. Okay? You just have to give your commitment and dedication to it. Okay, spend time as well. Okay, if you are spending time in your training to be very good rugby player or soccer player, Why can't you do it also in mathematics? Huh? That's a very good question, because remember, whatever course you are going to take up when you will be in the college or university, I'll tell you there is always mathematics. Or even in our everyday life, there is always mathematics. Okay? So listen to the expert. Okay, next one. Okay, so let's now proceed to the example of expanding and simplifying. So let me give you this example. So let's have this example. Okay, example in simplifying an algebraic expression. So the instruction would be expand, and simplify. Okay, simplify. Okay, expand and simplify. Can you still see it there? Okay, now let's have to simplify, to expand and simplify. Let me give you this example here. Number 1. Can you still see me? Okay, I'm writing it here. Example 3 2a plus 5. Okay, what would be the answer? The second one, I hope you can still see it there. A and a minus 7. Then we come this way. Okay, and then we come this way to continue the example. All right, our third one here. Okay, let me erase this part so that we can we will have more time, more space here for our example. Okay, our example. Remember, hey guys, I spend my money to have all of these, all the stationaries, and even this whiteboard. I have to spend my own money because I am really committed to help you. Okay, so I hope that you will also respond to this outreach of mine. Okay, I want you to be very good at maths, so please take time for this. So this is our example. I think it's not clear, so in our example, okay, so I'll say expand and simplify. Expand and simplify. So to expand means you are going to remove the brackets, and then you are going to simplify it. Now, in your grade 8 national examination for Papua New Guinea, or in any mathematics, sometimes the instruction in your exam is expand and simplify. Other times, it will be just simply simplify, because it is already understood that you have to apply all those rules of simplifying algebraic expression. This usually appears in the higher grades like grade 11 and grade 12 instruction, where we will no longer, or you will no longer encounter an instruction to be expand and simplify. Okay, to the higher grades, the instruction will be just simply simplify. But for grade 8 in the national exam, there is always an instruction of expand and simplify. Other times, it will just be only simplify. Okay, but please master the rules of simplifying algebraic expression. Okay, so we have number 3 over here. Number 3, we have negative 4, and then open 3x plus 2. Okay, number 4, I'll have to circle that, circle this, circle this one as well, so that you will not get confused. And then we have negative 3, and then negative 7a minus 5, and then we have this next example, number 5. We have 2 times y minus 4, and then plus 5 3x plus 2, and then we have number 6. Number 6, we have here the number 6, 2 open 3 minus y minus 2, this is open, plus y. Okay, and then the seventh one, 5 2 c, this is c, plus 6 minus 4 3c minus 2. Okay, so let me rub this one out so that we can only view the questions that they are presented here. Okay, all right, so expand and simplify. This example, expand and simplify. So what do we do here? What do we do here? So this one here, the rule number 1 is you are going to multiply by factors. We have 3 in order to remove the brackets. So you're going to remove the brackets. So we have 3 times 2a. So 3 is a positive. Okay, so 3 is a positive. So I'll have to position this side here so that you will say. So 3 is positive, and the operation outside the brackets is multiplication. So that would be multiplication over here, 3 times 2a. So that would be positive 3 times our 2a is also positive 2a. Okay, sorry, this should be positive 2a. Okay, now take note that in algebra, any expression or any term that doesn't have a sign means that it is a positive term. Okay, so 3 is a positive, and then 2a is a positive as well. Okay, so next we have the next one is 3 times positive 5. So positive 3 that doesn't have a sign is understood to be positive. Multiply it by a positive 5. So that will be positive 3, multiply it by positive 5. Okay, so I am going to use brackets here so that you will separate this expression or this term by the multiplication operation. Okay, so now I'm sitting it down here so you can only focus this one. So we have positive 3 times positive 2a equals, the answer is 6a. Why is it 6a? Why is it that when we multiply 3, positive 3 times positive equals positive, and then 3 times 2a equals 6a? Why? Okay, very good. Okay, we multiply 3 times 2 equals 6, and you just have to copy the a. So 3 times 2a equals 6a. 3 times 2 equals 6. Just copy the a, attach it here. So that's why we have 6a. You get it now? Okay, so this one is done. The next one is plus. We copy the plus sign there. positive 3 times positive 5. Now I copied the plus sign here, but actually you have to be careful. You have to be careful because when you are going to multiply positive 3 times positive 5, the answer is actually positive. Okay, so that this first example is okay. But be careful, you have to make sure that when you multiply positive 3 times positive equals positive. So you can first multiply the sign, positive times positive equals positive. And then later on you can do 3 times 5 equals 15. Therefore, the simplified answer of this expression here is 6a plus 15. You get it now, huh? Okay, very good. So let's proceed to the next one. The second example is a times a minus 7. So we have here positive a multiplied by, okay, so again, this is a multiplication operation here. So a times positive a. So I am now going to use a symbol here to separate positive a to with the times so that you will not get confused. Okay, and you don't have to worry because the operation is the same. You have to a times a. The next one is a times negative 7. So again, I am putting it here. Positive a, you multiply it by negative 7. Now again, I will use a symbol here to indicate the negative 7. Usually in mathematics, once the sign of an expression or a term is negative, we usually use a symbol to separate it. Okay? So that you will not get confused. Okay. Then the next one is we have now, can we still see it there? Okay. All right. So we have now, looks like we cannot see it. So let me just go down a little bit. Okay. All right. Now you can see. Okay. So we have a positive a times positive a. So positive times positive equals positive, or you don't need to write positive symbol. Okay? Because positive times positive is equal to positive, and oftentimes we don't need to write down positive sign with the given term. Okay? Then we multiply a, this one is a, multiplied by a. What do you think is the product when you multiply two a's? A times a. What do you think is the product? Okay? Very good. We are going to apply the rule of exponents or the rule of indices, the law of indices. Law of indices number 1 is when you are multiplying the same term, okay, the same base, you are going to add the power. So in other words, this letter A here is understood to have a power of 1. So this A here has a power of 1. The other A also has a power of 1. So therefore, it will now become A 1 plus 1. Why is it that we are adding the power 1 plus 1? Huh? Tell me why, when we are multiplying the same base, A, multiply it by A, why are we adding the power? Very good. Because in rule of indices or the law of indices, it states that when you are multiplying the same base, you're going to add the powers. So that's why we are adding 1 plus 1. Okay? And then we'll finalize it later. Plus, up. There's something wrong here. Okay? We cannot put yet plus here. We cannot put plus there yet because we are going to say positive times negative. Okay? Can you remember your rule of integers? When you are multiplying unlike sign, unlike means different signs. Positive times negative. What is the sign of the product? Huh? Tell me. Okay, very good. Negative. Even if you interchange it, negative times positive, the product is negative. Okay? So positive times negative equals negative sign. It's negative sign. Then, from there, you can multiply A times 7. What is the product when you are multiplying a letter multiplied by a number? Huh? Very good. The answer is 7A. 7A. Okay? It is 7A, not A7. Because the standard of writing an algebraic expression is it must be first the numerical coefficient followed by the literal coefficient A. So this one is an algebraic expression 7A. You cannot say A7. This one is wrong. Okay? That is wrong. It's supposed to be 7A. So now we have 7A. So our final answer now is A squared, or A to the power of 2, minus 7A. So A to the power of 2 minus 7A. Can you get it now? Okay. Next one, we come to the third example here. We have negative 4 times 3A. Okay? You cannot see me anymore, huh? Okay, it's okay. The most important here is you can hear my voice while I am explaining this third example. So negative 4 times positive 3x. So it should be written like this. Negative 4 times 3x. Now, because to avoid confusion, because this x is also a sign of a multiplication operation, so you can use brackets here. Because our x here is also used as a literal coefficient. Okay, the next one is negative 4 times positive 2. So that is negative 4 times positive 2. Can you see it? Okay. Negative 4 times positive 2. Look at that one. That's multiplication operation. So here you multiply first. Negative times positive equals negative. And then 4 times 3 equals 12x. Okay, 12x, 4 times 3 equals 12, and then you just have to copy the x. So that is now negative 12x. Okay, and then the next one is negative times positive is negative. Okay, then we have 4 times 2 equals 8. So the final answer now is negative 12x minus 8. Okay? Are you following? Are you following, guys? Are you following One Talks? Are you following Kababayan? Are you following students around the world? Okay. So thank you for still sticking with me, this is for you. Okay. Next one, we have negative 3. So in order to give us a space, I will first remove this one now, so we can have another space. Okay. Okay, so we have number 4 is negative 3 times negative 7a. So that would be negative 3. Let me remove this one, the number 5, and then I'll just do it later. So negative 3 times negative 3, this one negative 3 times negative 7a, negative 7a. Okay, now again, our 7a term has a negative sign, so we can actually use the symbol parenthesis here in order to separate it. Next one is negative 3 times negative 5. So we have negative 3 times negative 5. So we can have another bracket here to separate it. So our final answer now is negative times negative is positive. Okay, so the answer is positive. 3 times 7 is 21a, and then this one is negative 3, negative times negative is positive. Now take note, please recall your rule of integers in multiplying numbers. Okay, negative times negative is positive, and 3 times 5 is 15. Okay, now our final answer here will now become 21a plus 15. Okay, 21a plus 15, because we don't need to write a positive symbol here because this is already understood to be positive. Okay, I hope that's clear to you. Next one, we have our number 5 question. Let me do it here, number 5. Sorry for that movement there. Okay, so I have deleted the number 5. So the number 5 is 2 times y minus 4 plus close plus 5 open 3y plus 2, 3y plus 2. Okay, so that's our given there. So this expression is complex, but you don't have to worry because the same thing as what we did there, you are going to make sure to expand this expression. When you say expand, you are going to remove these symbols here, these parentheses here or brackets. Okay, and to remove that is to multiply it by the factor outside the symbol. So we have now 2, this one, 2 times y. So we have positive 2 multiplied it by y. Okay, and the next one is 2 times negative 4. So that is positive 2. So this 2 is positive. Multiply it by negative 4. So I am going to use this symbol to indicate that 4 is has a negative sign. Okay, so we are done removing the first symbol. Next is to remove the second symbol. Now take note, our 5 here has a positive sign. So that means that positive 5 times positive 3y. So that would be positive 5 times 3y. Positive 3y. Okay, because our 3y here is understood to have a positive sign. Next one is positive 5 times positive 2. So we have positive 5 times positive 2. Okay, so this is a step-by-step way of working it out. So the next one now is you are going to, so we have positive 2 times y equals 2y. You get it? So this is now our rule number 3 expanding, and we are going to collect like terms later. Then positive 2 times negative 4. What will be the answer? So positive times negative. What is the product? Positive times negative equals negative. Okay, so the sign is negative. Then 2 times 4. 2 times 4. 8. Very good. Okay, so we are done on this part here now. Next one is positive 5 times 3y. So that is positive 5 positive times positive. What is the product? Positive sign. 5 times 3. 15. Very good. That's 15. And then you just have to copy the y because it doesn't have common over here. So 15y. 5 times 3y equals positive 15y. Next one is positive 5 times positive 2. So that is positive times positive. What is the sign of the product? Positive. Very good. So that's positive. And then 5 times 2. 10. Very good. That is now 10. Okay. So this is now the rule of simplifying algebraic expression number 3, in which you are going to collect like terms. Okay. Now in this expression here, what are the like terms? What are like terms again? Can you tell me? What are like terms again? Yes, very good. The like terms are, you are going to check the literal coefficient. This one here. This is 2y and this is 15y. So that is 2y and 15y. Now take note, these two terms are like terms because of the literal coefficient y. This is y and this is y. The numerical coefficient 15 and 2, no, that's not the one that you are going to look up in finding out the like terms. It's all about the literal coefficient or the letter. This is y, this is also y. So this one, 2y is positive. This one is positive. So you are going to say positive 2y plus 15y. So that is 2 plus 15.